For the sightless, mobility has always been an issue. It's a serious problem. How do you see where you're going in an environment that is just filled with obstacles that sighted people like us just take for granted? I'm with Riya Karumanchi. She's founder of Smart Kane. Riya, I understand you have developed a device which is deceptively simple in appearance, but this could really help the sightless get around. Tell me about it.
So it started off as a chance encounter at my friend's house, and I saw her grandmother who had some mild visual impairments. So that got me thinking, and it pushed me to do more research, and I noticed that the cane was never updated to take advantage of new technologies. And that was crazy because it's 2017 and it's still a stick. So I did a lot more research, and I came up with the idea of a smart cane. So with a partner, the School Science Fair project presented an opportunity to address this issue and come up with a solution. So with a partner, I created a prototype of the smart cane, and then we won at our school fair and advanced to the regional science fair, and it really escalated from there. So I'm really glad that I chose to take it forward. I really wanted to improve the visually impaired people's lives. So I didn't expect that it would come this far, but it's great, and I really hope it gets into the market soon. So the Smart Cane is an assistive device for orientation and mobility for the visually impaired. So it leverages advances in technology to help increase independence and safety. So the Smart Cane detects obstacles in front of the user and vibrates to let them know if anything is in their path from knee to head level. It's integrated with map software, so using varying vibrations, haptic feedback, and audio feedback, it helps direct them to go to their destination. And there's also an emergency button on the cane, so that when pressed, it automatically notifies emergency services and provides them with their name, medical history, and location details, so they can come and get them efficiently. And there's also location sharing to notify caregivers, interveners, or family members where they are, and light and wetness sensors, which are optional.
Wow. Now, haptic feedback, that's something which historically, it has a long history. It goes back, for example, in the aerospace industry where artificial feel was introduced into aircraft controls to give a pilot a sense of control. But these devices were expensive, large, bulky, difficult to engineer. We're talking about a cane here. That's a very, very tiny device. How did you manage to get haptic feedback into something as small as a cane?
Yeah, so we were able to miniaturize the vibration motor small enough so you can put it into the handle. So using varying vibrations, so let's say if you had to turn left or right, if you have to turn left, it would vibrate once. You have to turn right, it would vibrate twice. And different commands like that would help direct them to their destination. So yeah, we were able to fit the motors and make them smaller and put them in the handle of the cane. So the device, definitely, we wouldn't want it to be bulky. We want it to be easy to use, so we have an ergonomic grip. And yeah, so we're currently working forward to miniaturize the technology more.
And how does it sense its objects in its proximity?
It uses an ultrasonic sensor as of now to detect objects from knee to head level. So it has a good range and good sensitivity, and we are looking to get some improved sensors to adhere to different weather conditions as well. So the ultrasonic sensor sends out ultrasonic waves and measures the distance from the user to an object that comes in the path. And using an if-then statement within the code, if there's an object detected below 2 meters, it'll vibrate.
Is there an onboard processor that takes that data from the sensor and processes it?
So right now we're using a microcontroller called an Arduino, but later on we're working to move away from the microcontroller and create our own chip using a PCB design.
Yeah, I know the hackability challenge was a factor here. Tell me about that aspect.
Yeah, so the hackability challenge was wonderful. So it was a 2-month extended hackathon, and there was multiple sponsors and a lot of people to help. So we received different mentors and formed a team of 10. And for the 2 months, we were working on developing the Smart Cane further. And in December last year, we pitched our idea to a panel of industry professionals, and we actually ended up winning. So the prize package was pretty big. It involved a series of different prizes and services to help accelerate further development of the Smart Cane. So different companies like Microsoft, Inertia, Arrow, Engineering.com, and Your Start, and there's a lot. So I think that's really going to help with further development. we definitely wouldn't be where we are now without Hackability. So it was such a wonderful experience, a great learning experience, and yeah, it was awesome.
How do you coordinate a team? You have a significant number of people. You talk about 10 people in your team. So how do you communicate between them? I mean, email is one way to do it. That sounds a little awkward.
Yeah, so emails are a little more formal. So what we really liked was we used the engineering.com platform that you guys have. So that was really cool, and it was a good way of having a platform where people can all communicate informally, and you can have access to direct message and also a whiteboard where you can also, everyone can edit it, and it's really a really good way to collaborate with one another, and also an amazing way to form teams. So that was one thing that I was struggling with at the beginning, is forming a good team. So I think that the engineering.com platform really helped within the Hackability project, and the organizers helped guide different people who were looking to join a team and people who had ideas and connected them together. So that was a really cool part of the platform.
What's the future for Smart Kane? Do you envision mass production, widespread availability?
Yeah, so I definitely envision mass production, widespread availability. I definitely hope to get into the market and sell it through the CNIB, which is the Canadian National Institute for the Blind. So we have established connections with the CNIB and have some conversations going on that side. And yeah, so I really hope we get into manufacturing and finish our minimum viable product and then get it into the market.
Now, one beauty of a Kane, of course, is it's relatively small, relatively light, and it's fairly easy to ship things around the world. Can you envision perhaps a widespread adoption, US, Europe, Asia?
Yeah, definitely. So we want to start in Canada and then later expand to Europe, the United States, and also some other third world countries to really help countries with a lot of visually impaired people.
Riya, how old are you?
I'm 14.
And Riya, I understand you're in the 9th grade?
Yeah.
The future of engineering, a 14-year-old 9th grader producing a socially useful, high-tech, and impressive piece of technology. That's Riya Karumanchi at Smart Kane.